The story so far is that we've started with this cubic polynomial equation, z cubed minus 9z squared plus 21z minus 5 equals 0. And we used a mechanism of a change of variables, a rigid horizontal shift of the graph to depress the cubic equation, to wind up turning it into a new cubic equation, x cubed minus 6x plus 4 equals 0. Now this polynomial in the new variable x has a graph that looks just like the previous one, except it's been shifted to the left 3 units. And so that's moved all of the x-intercepts, all the solutions to this equation, 3 units to the left of where they are in the original equation. The previous video, I went through and illustrated the method of Cardano, which is laid out in detail in my notes on Chapter 5, as well as Chapter 5 of the text. And so the method of Cardano modified this notion of replacing the variable with a new variable plus a constant. Instead, we used two variables, u and v, and we worked through the method and found that we got values for u cubed that involved the square root of -1, or the square root of a negative number. At Cardano's time, the complex numbers had not been invented or discovered, and so Cardano called this by a name that just says, basically, I gave up, something called the casus irreducibilis. And the casus irreducibilis, then, was a place where Cardano had to say some cubic polynomial equations just don't have a solution. Well, we forged ahead with his method with the benefit of hindsight, using the complex number c, and we were able to work through and show that this equation for u cubed, that number on the right hand side actually has a cube root. And so depending on whether you take the plus or minus case in the value for u cubed, you either get u equals 1 plus I, or you get u equals 1 minus I. And then for each of those values of u, it turns out you get a matched value of v. So when you have 1 plus I for u, you get its conjugate, 1 minus I for v. And if you get 1 minus I for u, you get the conjugate of that, 1 plus I for v. Now we'll detail our treatment of the complex numbers more in Chapter 6, but just based on that, if we recall that x was equal to u plus v, then if we add u and v, we find out that x equals 2 is a solution to the depressed cubic polynomial equation. And so with x equals 2 being a root, then x minus 2 was a factor. We divided that out and determined that using the quadratic formula on the quadratic factor that remained, that there were two more roots, -1 plus the square root of 3 and -1 minus the square root of 3. Those were the three solutions to the depressed cubic, x cubed minus 6x plus 4 equals 0. Now, once you've got a value of x, we have a recipe, add 3 to it, and you wind up getting a value for z in the original equation. So to summarize, we have this depressed cubic that has three solutions. Using the change of variables equation, we're able to then turn those three solutions into three roots for the original cubic polynomial equation. And 5, okay, you know where that is on the x-axis. I've gone ahead and put in decimal approximations for 2 plus the square root of 3. That's about 3.73205. If you remember, in the first video that we did, we actually looked at the graph on the first video on this material. We saw that there was a root between 3 and 4, an x-intercept of the graph of the original polynomial, and that the original polynomial had another x-intercept, we thought, a little bit to the right of 0. Well, this is consistent with that behavior. The other root, being 2 minus the square root of 3, is about a little bit more than 1/4. Of course, Cardano couldn't get that far because Cardano was stuck with trying to take the cube root of a number that didn't exist in his world. But Francois Viete figured out a method to avoid this. It's a completely different approach. I've detailed the derivation of the method in my notes of Chapter 5. You should look carefully at the notes because they are more extensive than what appears in the book, and there are a couple of places where the author in the book got a little bit sloppy with negative signs. So I have corrected those in my notes. So our next thing up will be to open up with Viete's method. So on to another page.